Good morning dear students. Today we are going to start chapter number 3, that is motion in a straight line. What is motion? So for the motion, for example, we will consider point object at every place in the whole chapter and in whole physics, right? So we will consider object as a very much smaller point object, means very small object compared to the distance it travels. So, what is motion? The change in position of an object with respect to time is called motion. Then, motion in a straight line means an object is changing its position with respect to time in a straight line. So, the motion in the straight line is also known as the rectilinear motion, is also known as the rectilinear motion. So, you came to know that what is motion and what is the motion in a straight line called. It is known as the rectilinear motion. So, we have completed chapter number 4, that is vectors. In that chapter, we have completed all the topics of this chapter also. But again, we are going through the according to the book, all the topics according to the book. You all know all these physical quantities and their units also. I have, in the last lecture, I have taught you what is the dimensional formula and how to write it, right? So that will be important, and at the end of this chapter, one blue color table has been given in which physical quantities, their symbols and dimensional formulas are mentioned, that you have to prepare well. Okay. So first of all, the introduction of this chapter number 3, that is motion in a straight line. So motion in a straight line, here for the introduction, you know that as we are when we are awake, we walk, we run. So that all is the changing position with time, that is motion. Again, in universe, the earth revolves around the sun, or it rotates along its own axis, right? So that is also motion. Sun itself is moving in the Milky Way, right? So everything is motion. When we are asleep, so at that time also, the air we inhale and exhale, that process is continuously going on, that is also motion. The blood is flowing inside our body through our arteries and veins, that is also motion. So motion is everywhere in this universe. Again, kinematics. What is kinematics? Kinematics is the branch which studies motion without its cause, without knowing its cause of motion. So that is topic number 3.1, that is introduction of motion. And next comes, there are total 7 topics in this chapter. Next is the position, path length and displacement. So first of all, we will consider what is position. Say for example, I am standing here, right? So this is my position. So we will consider that what is reference point, what is the frame of reference. These are the terms which we need to define at this early stage. Okay. So in next chapter, that is chapter number 4, which we had completed. So in that also we have studied all this topic, that was what is position, what is path length, what is displacement, what is velocity, what is acceleration, right? So here for the position, so we need to consider the coordinates. You also know about the one-dimensional, two-dimensional and three-dimensional geometry. So for one-dimensional, for example, one dimension. For one dimension, there is only one axis. Say for example, this x-axis. This side positive x-axis, this side negative. So this is for the one-dimensional motion. Now comes two-dimensional motion. So this is your two-dimensional motion. Now this is your two-dimensional motion. That is x-axis and y-axis. Clear? Then comes three-dimensional motion, having the three coordinates. That is, say for example, x, y and z. Clear? So you may also see like this in the book. In book it will be, this is your two-dimensional motion. This is your coordinate system for three-dimensional x, y and z axis. So the point of intersection of the coordinates axis here for two-dimensional x and y coordinate intersect here. So this is your origin, or you can say the point of reference. Again, in three-dimensional x, y and z, there are three coordinates, and where they intersect, that point is your origin, or you can say the frame of, or you can say the reference point. Now, what is frame of reference? There is only a minor difference between the reference point and the frame of reference. So, this intersection point where everything is zero, right, all the parameters are zero, that is your reference point. But when the time is introduced in it, means the change in position of an object along xy or xy or z axis with respect to some time interval, then that point is known as that frame is known as the frame of reference. Clear? So first of all, what is position? So position can be at any place at any time. But for that, what is reference point? So for two-dimensional, three-dimensional or one-dimensional, the origin point, the point where all the coordinates intersect is your origin point, or you can say reference point. Again, when the change in position of an object along x, y or both axes at a specific interval of time, then it is known as the frame of reference. Clear? So that is your position. Next comes the path length, and another one is the displacement. This path length is also termed as the distance. Again, so what is path length and what is the displacement? So the difference between these two are, path length means the total path covered, and what is displacement? That is, displacement means the distance between final position and initial position. That is displacement. So say for example, take any example. Say for example, this is person A. Clear? This person A moved here 3 meters. He moved here 2 meters and here 1 meter. Right? So the total path length of person A traveled from here to here is 6 meters. So what is total path length? This is your path length. The person moved 6 meters. So 6 meter is your distance or the path length. Now, if we need to find the displacement. Displacement means the direct distance between the final position and the initial position. Clear? So this is the displacement. Got it? What is path length and what is displacement? The unit of path length and displacement, both is the length. So its unit is meter. Clear? Its SI unit is meter, and its dimensional formula, unit of displacement is meter, and its dimensional formula can be written as mass is not there, length is in meter 1 and T0, that is M0 L1 T0. Clear? Now comes the next topic. So here you came to know that what is position, what is path length and what is displacement. Now average velocity and average speed. Before studying this, we will study about what is velocity and what is speed. So first of all, what is speed? Speed means distance upon upon time. So this is your speed. What is velocity? Velocity is displacement upon time. Path length, velocity is displacement upon time. Clear? What is speed? Speed is distance upon time and velocity is displacement upon time. So here its unit will be the same because distance or path length can also be measured in meter per time, that is second, meter per second. The velocity, that is displacement upon time, the unit of displacement is meter and unit of time is second, that is meter per second. So its dimensional formula will be m0 L1 t minus 1. Why minus 1? Because meter per second. This denominator when comes in the numerator, then its power is, here power is 1, then when it comes to numerator it will become minus 1. Here mass is not there, so mass 0. Length is meter L1. Time s minus 1, so t minus 1. So what will be the dimensional formula of speed and velocity? That is m0 L1 t minus 1. What is the unit of speed and velocity? That is meter per second. Clear? So this is your speed and velocity. So here the change in displacement upon change in time. Say for example distance in displacement is for example s or x. So velocity will be equal to delta x by delta t. Now comes the average velocity. What is average velocity? You all know in mathematics that what is average? Average is the total of this distance upon time. Here total displacement upon time, change in time, right? So that will be your average velocity. That will be your average velocity, that is x2 minus x1 upon t2 minus t1. This will be your average velocity. So that is your average velocity and average speed. In speed you have to write about the path length and here for displacement. Next comes instantaneous velocity and speed. So first you came to know what is velocity. Then what is average velocity. Then comes instantaneous. This average velocity just says us that what is the average of the speed of an object in the path, on the path. So, but instantaneous means, for example, consider one straight line. At this point and at this point, the average velocity is say for example 5 meter per second. But do you know that what is the velocity of an object at this point? What is the velocity of an object at this point? So at each and every point we don't know that what is the average. Average velocity is the average of the total path covered. Clear? What is average velocity? That is the average of velocity, because velocity may be different at different point. So average is for the whole path, but what is the velocity at that specific point, that specific position, at that specific time? So for this you must understand one simple example. If we are traveling from Adipur to Bhuj, we are the object, right? So we are traveling from Adipur to Bhuj. So the distance is 50 kilometers. Clear? So we travel 50 kilometers in 1 hour. In 1 hour. So here consider velocity equal to displacement. How much? 50 kilometer. We travel in how much time? That is 1 hour. 1 hour is your 3600 seconds. So this is your 50 per 3600, or you can say 50 kilometer per hour. Velocity equal to 50 kilometers per 1 hour. So velocity is 50 kilometer per hour. Here distance is in kilometer and time is in hour. So this is your velocity. So means if you are saying to someone that you travel from Adipur to Bhuj in 1 hour. But if someone asks you that what was your speed at this Anjar go line, right? So at that you don't know. Clear? So for that we introduce the instantaneous velocity, or you can say instantaneous speed. So means you are traveling from Adipur to Bhuj, which has a distance of 50 kilometers. So if you want to know that what was your speed or what was your velocity at this point, say for example Anjar go line. Clear? So at this point, what was your velocity? So that is your instantaneous velocity. Got it? Or else, if someone asks you that what was your speed near, say for example, Chosat Bazaar. So, or what was your speed at Mundra Sarkar? So that point, that specific distance at specific time, what was your velocity? That is your instantaneous velocity. So for finding the instantaneous velocity, we need to limit. So that is instantaneous velocity equal to limit delta t tends to 0, delta x by delta t, that is equal to dv by dx by dt. Getting? So instantaneous velocity is the limit of time at specific distance, that is dx by dt is your instantaneous velocity. For this, for same, you can write for the speed also, that is the distance, that is path length by time, that is the limit of delta t tends to 0, delta x by delta t. So did you understand the concept of instantaneous velocity? Clear? So first, velocity, that is simply we travel this much distance in this much time, then average of different segments of the distance in different time, that is average velocity. Then comes the instantaneous velocity, that is at a specific instance. Then is your acceleration. What is acceleration? That you have already studied in chapter number 4, that acceleration is the change in velocity per unit time. What is acceleration? Change in velocity per unit time. In acceleration also, there can be instantaneous acceleration, means the acceleration at a specific point at a specific time, that is your instantaneous acceleration, and for that you have to take the limit of the velocity. So for acceleration is your delta v by delta t. For instantaneous acceleration you have to take limit delta t tends to 0, delta v by delta t, and that is dv by dt. Clear? So that is your acceleration. When an object is moving with uniform velocity, right? So for example, its speed is same or its velocity is same, so it is known as the uniform motion. Clear? That is uniformity in speed or acceleration. Kinematic equation for uniformly accelerated motion. So there are different equations. This you have studied in standard 9th also. That is v equal to v0 plus at, or you can say x equal to v0 t plus half at square, or you can write v square minus v0 square equal to 2a displacement, velocity and acceleration. So in this chapter there are very nice numericals in which when an object is thrown upward or an object is free fall downward, then what will be its velocity, what will be its acceleration, at what time it will reach the ground, or at what time it will reach the maximum height, right? All these are very interesting numericals. So using this formula you can find out the unknown quantities, that is either displacement or velocity or time or acceleration. Clear? So here V, what is V? V is your final velocity. What is V0? V0 is your initial velocity. A is your acceleration and T is your time. X is the displacement. Clear? So V equal to V0 plus AT, X equal to V0T plus half AT square, V square minus V0 square equal to 2AX. These are for the linear motion, or you can say rectilinear motion. So this can also be written in different ways, that is V equal to V0 plus AT. At the place of this displacement there may be D, or it can be written as S, or it can be written as X. So the displacement can be shown in any quantity or any symbol, that is D, S or X. So you don't need to be confused, right? Got it? So here at the place of X, that is displacement, here or here, there may be D, S or X. So here D, S and X describe the displacement. Clear? Now next topic, that is 3.7, relative velocity. For this, say for example velocity of A and velocity of B. If we want to find the relative velocity of A and B, that is velocity of A with respect to B, that will be equal to VA minus VB. Velocity of B with respect to A equal to VB minus VA. So from here you come to know that VAB equal to minus VBA. But the magnitude of this relative velocity will be equal. Clear? So this was your relative velocity, that is when there is velocity of object A and velocity of object B, then velocity of A with respect to B and velocity of B with respect to A are opposite, that is minus VAB equal to minus VBA, and their magnitudes are same. So in this chapter you need to read the whole chapter. If you have any doubts, then you may ask at any time on WhatsApp or call. Again, you need to read the summary of this chapter and the dimensional formulas given at the last, that is physical quantity has been given, their symbol, their dimensional formula, that you have to by heart and you have to understand. If you don't understand, then ask. Also dimensional formula of acceleration, that is what is the unit of acceleration, that is meter per second square, that is meter second raised to minus 2. So dimensional formula will be m0 because there is no mass. m0 L1 T minus 2. So this is the dimensional formula for acceleration. Clear?